For years, astronomers have been waiting for the next interstellar visitor, something to follow Oumuamua and Borisov, something that could finally answer the questions we've been too afraid to ask about what lies beyond our solar system. Nobody expected it to arrive so quietly. No fireworks, no global panic, just a faint streak of light discovered by an automated survey camera. But that streak would soon become the most controversial object in the sky, the interstellar comet now known as 3I Atlas. At first, it looked like just another icy wanderer, drifting through the void on a path that made no sense. It wasn't bound to the sun. It wasn't looping back around like normal comets. It was passing through, a visitor from somewhere far beyond the reach of our star. But every day since its discovery, 3I Atlas has refused to behave like the universe says it should. It rotates strangely. It brightens at the wrong times. It dims when nothing is blocking it. And its structure, the very material it's made of, has sent scientists back to the drawing board. Something about this object isn't just unusual. It challenges the basic story we tell ourselves about how objects form in space. And now, with its 2025 close approach approaching, 3I Atlas might change everything we think we know. The first sign that 3I Atlas was different came from its motion. Not its speed, its behavior. Normal comets brighten as they move closer to the sun because heat evaporates their icy surfaces. But 3I Atlas brightened early, then dimmed, then brightened again. It pulsed like something was happening beneath its surface, as if it wasn't just reacting to sunlight, as if it had internal processes we don't understand. Some suggested that it was simply shedding material in bursts. Others argued that the structure of this object is unlike anything we've seen before. Brittle on the outside, but possibly layered inside, containing pockets of volatile substances that ignite unpredictably. But even those theories didn't explain everything. Because shortly after the first observations, astronomers noticed something else. 3I Atlas wasn't shedding material in a normal direction. Instead of leaving a tail behind it, the dust and gas sometimes streamed ahead of the comet, pointing toward the sun instead of away from it. An anti-tail, a feature only seen in rare, fragile comets with strange geometry and complex dust behavior. But it wasn't just an anti-tail. The structure of that tail kept shifting, twisting, changing shape in ways that looked less like dust and more like something pushing back, something interacting with solar radiation in a way that shouldn't be possible. A few scientists whispered a controversial theory. The dust grains coming off 3I Atlas might be unusually porous or unusually large, responding to sunlight differently than typical comet dust. But even that explanation struggled to make sense of the behavior. Whatever Atlas is made of, it reacts to sunlight in a way that no other interstellar object ever documented has. Then came the next shock, spectroscopy. When scientists broke down the light coming from 3I Atlas, they found chemical signatures that didn't match the typical profile of a normal comet. Yes, there were volatiles, but the ratios were strange. Some gases were weaker than expected, others were strangely abundant, and a few signals suggested the presence of compounds that aren't usually found in young solar systems, materials that form under extreme conditions. This wasn't an object formed near a star like ours. It came from somewhere different, a region of space where chemistry takes place at temperatures and pressures that don't exist within our solar system. And that means something profound. 3I Atlas is a sample of another world, another star system, another cosmic environment, a fragment of a place we have never seen, never visited, and never understood. If it formed in a system completely different from ours, then the rules of planetary formation might not be universal. The universe may not build its planets and comets the same way everywhere. The blueprint we've been using, the model based on our own solar system, might be just one version among countless possibilities. But the most mysterious part of 3I Atlas isn't its structure or chemistry. It's its trajectory. Interstellar objects don't follow clean, predictable paths. They wander in from deep space on hyperbolic orbits. But 3I Atlas isn't just wandering. Its angle of entry puts it on a course that practically slices through the solar system like a scalpel. Experts began calculating its origin, trying to trace it back to a parent star, but the path pointed toward a region of the galaxy with no known system that could have ejected it. Then a bigger question emerged. What if this object has been in interstellar space for billions of years, traveling between stars? carrying the chemical history of ancient worlds long gone. Comets inside our solar system are time capsules. But 3I Atlas is something greater. It is a messenger from a region of the galaxy we may never reach in person. A cosmic refugee carrying secrets older than the sun itself. As astronomers studied its motion more carefully, some noticed tiny deviations, small shifts that suggested something more than just gravity was acting on it. Not as dramatic as Oumuamua's unexplained acceleration, but strange enough to raise eyebrows. Was sunlight pushing it differently because of its unusual shape? Or was the comet venting gas in ways too subtle to detect directly? Some have proposed that its surface might be incredibly dark, absorbing heat unevenly and releasing jets from deep inside. Others think the entire structure might be much more fragile than expected, like a loosely bound snowflake the size of a mountain. A few outside voices whisper theories about exotic materials, porous carbon networks, dust grains shaped like needles or fractals, structures that interact with light in ways we don't fully understand. Nothing points to technology, but everything points to nature doing something we never predicted. That's the real power of 3I Atlas. It forces us to admit that the universe is not obligated to make sense according to our rules. When it reaches its closest approach in late 2025, we will see it brighter and clearer than ever before. New telescopes, ground-based, orbital, and even amateur observatories will capture images and spectra that we've never been able to collect from an interstellar visitor. This is only the third confirmed object from another star system to enter ours, and it may be the first that allows us to study its physics in detail. If Atlas continues its erratic brightness patterns, it could reveal internal structures we never imagined. If its anti-tail persists, it could rewrite how we understand dust in low-gravity, low-pressure environments. If its chemistry remains unusual, it could prove that planet formation across the galaxy is far more diverse than we ever predicted. If its orbit shifts even slightly, it might force us to refine, or even rewrite, our models of non-gravitational forces acting on interstellar bodies. And if it matches no known category of comet or asteroid, then we may have to create a new one. Because this isn't just a comet. It's a challenge. A challenge to everything we think we know about how other star systems are built. A challenge to our ideas of what can survive in deep space. A challenge to our assumption that all comets everywhere follow the same rules. 3I Atlas is a reminder of the universe's greatest secret, that we understand almost nothing. Our solar system is one tiny neighborhood. Our physics is one interpretation. Our expectations are shaped by the tiny corner of space we grew up in. But this object, this faint, icy traveler, comes from somewhere far beyond our cosmic backyard. It carries a memory of ancient stellar collisions, a fingerprint of chemical skies we've never seen, a pattern of dust shaped by forces that don't exist here. It may hold clues about life-bearing molecules, or the building blocks of exotic planets, or the debris from a star that died before humanity existed. And if we can decode those clues, even a little, it will change everything. Because studying 3I Atlas isn't just about understanding a comet. It's about understanding ourselves, and our place in a universe filled with worlds we haven't discovered yet. For the first time, we're not just looking at distant stars and guessing. We're holding a piece of another system in our telescopes, a relic from a place we may never visit, but can now study as it races past us. 3I Atlas may be small. It may be faint. It may not have the dramatic shape of Oumuamua or the brightness of Borisov, but it has something far more important: unpredictability, complexity, mystery. And sometimes, mystery is the most valuable scientific tool of all. This object could crack open our assumptions. It could reveal the diversity of cosmic chemistry. It could prove that interstellar objects are far more varied than we believed. And it might show that our solar system is not normal, but just one strange example among billions.